PR. So now let's look at the steps to find the equation of a line. The steps. Step 1, find M. M means gradient, and now if you look at these, they give us the formula for the gradient. Let me come back to the formula here. We have the formula of the gradient. There it is, M is changing over changing X. There is the formula here, which is y2 minus y1 over x2 minus x1. Okay, and then if we can use that, M is equal to y2 minus y1 over x2 minus x1. So we find the gradient. So we're gonna find it. Number 2, use y is equal to mx plus c to find c. Hello, our most valued student. My name is Confident. Welcome to our revision session for you guys who are preparing for their final exams in Mathematics Level 3. And I want us to focus on question 1, which usually covers geometry. And as I say, it is for you guys who are doing their NCV. That's Level 3. And this channel or this YouTube page was designed with you in mind to prepare for your mathematics final exams. So this is the second paper, NQF Level 3, and I'm looking at a question that was written not long, but November 2021, and I'm looking at question number 1. As I say, it is on geometry, so we have to just look at a few things here. But now, before we do anything, I will encourage you guys to subscribe to this channel and ensure that the notification bell is turned on so that you are notified every time there's a new video. This is a new channel and it has got you in mind, so don't watch it alone. You need to definitely forward it to your friends and your colleagues so that I can get as many of you who need this assistance as possible. So just do it now. Forward the channel, share the channel, and be ready to get some information on this. So now, whenever we're looking at geometry, one of the key things that I want to bring to you while we're doing this question is I want to bring in close that you need to be sensitive to the formulas that you'll be using. So there is a lot of formulas that you have to rely on when it comes to geometry. So let's look at this question. It says a teaching aid supplier has spheres with volume of that number and diameter d. So you can see there is the diagram of a sphere in here. So this is the sphere with the diameter, and then she decides to melt, that's one word, one sphere and make one hexagonal pyramid from the material. So from this she made this, the hexagonal pyramid. The hexagonal pyramid has a regular hexagonal base with sides 15 centimeters and center O. So they're now giving us the hexagonal pyramid here. So we can see the side 15 centimeters and center O. Says the line joining the center to the midpoint M of side JK. So there is our M here. See that? Then this line here, the line joining M from center O. The line joining the center to the midpoint M of JK has length, so OM here is 12.99 centimeters. The perpendicular height O to the apex of the pyramid N is h centimeters. This is that. And then they give the information here. They're saying it's a regular hexagon. Remember, it's six-sided. Regular means it's got equal sides, so that's what the regular mean. So with that information, says show that the diameter of the sphere is 20 centimeters. Now which diameter? They're talking about this diameter. Now as I said, you need to rely on the formulas. So you need to know the first thing. They're saying a teaching aid supplier has a sphere with a volume, so we need to know it's talking about volume. So if we look at the formulas, now if I can bring in the formulas closer, so let's look at these formulas here at a close range. So we have got these formulas, and it's quite a lot of formulas that you need to familiarize with when it comes to mainly mensuration of shapes, is geometry. But now when we are talking about the volume of a what, look at this. We are dealing here, it says the teaching aid has spheres, so we want the volume of a sphere. So if I go to the formulas here, I'm looking at the volume, and the volume of a pyramid, volume of a cone. There we go. Number 14, volume of a sphere. And number 15, this is the area of a sphere. The volume of a sphere is 4/3 pi r cubed. So that's what I'm going to be using to say, if I know the volume of a sphere being 4/3 pi r cubed, let me write that. V of a sphere is 4/3 pi r cubed. And then the question is, they told me, they are saying that particular volume, says a teaching aid supplier has spheres with volume. They gave me the number there, that is 4188.791. so let me write this number so that I can move it with it there. So it's 4188.791. so that's the volume. So if I can take it in closer to this side, it will make more sense to you. So look at this. They are saying that particular volume, V, so this is our V. So you can see that we've got two V's, then we can equate these numbers. So if I can just duplicate this to say this number here is equal to that. You see what I'm doing there? That's it. So you just equate that to say 4/3 pi r cubed is equal to that, because that's the volume and that's the volume. So if you've equated it, after equating it, the next important thing is for you to find the final answer. So what do you do? I think the first things first, you can actually multiply by 3, multiply by 3. So what will I be having? This is gone, so I will have 4 pi r cubed is equal to 4188.791 times 3. Let's leave it like that. Let's not multiply it until the final answer. Then you can divide by what you don't want. We don't want 4 pi here, but what you do on the left, you do on the right. We don't want this 4 pi. So you've got r cubed is equal to 4188.791 times 3/4 pi. And then next we are looking for r. You cube root. Remember r cubed, how do you separate that? You cube root. So you put a 3 there. Again, what you do on the left, you do on the right. You cube root. Then you'll have now your r is equal to cube root of that. I think now I can use a calculator now to say, what is the cube root? Shift, which is that, which is cube root of fraction 4,188. Actually not 4, it's 4188,791, because that is a 1, and then times 3 divided by 4 shift pi equal to, which is 10,0000063. So if you round off, you can see that it's actually equal to 10. So it's 10 watt. The units here are centimeters, so it's 10 centimeters. Now the question was what? Show that the diameter of the sphere. Now you know that the diameter and the radius, how they link. The distance from the center, that distance there is the radius. So this is your r, and then the diameter is times 2. So you'll have the first, and then you got the second one like that. So these are 2 radii, which is 2 radiuses. So remember, which means D is equal to 2R. Are you seeing that? So here you can now finalize the answer to say if R is equal to 10, knowing that D is equal to 2 times R, which is 2 times 10, and it is 20 centimeters. They said what? Show that D is equal to what? 20 centimeters. So that is what? That is the answer there. Show that the diameter is 20. How many marks? You get 3 marks for that. And then the next one says, show that the perpendicular height of the hexagonal pyramid H is that. The perpendicular height. So we come here. They are looking at this distance here. This perpendicular height. But remember, it's like this. You've got that. But it's fine. And then they gave you this information here. There's 2 information here for you to find the perpendicular height. They gave us also this part to say the side of each is 15 centimeters. So they gave us that. So now calculate the what? They say we need to calculate, show that the perpendicular height of the hexagonal pyramid H is that. Now, as I said, formulas are very important. Now, if you're talking about the hexagonal pyramid, look at this. Number 6. Look at number 6 here. Surface area of regular hexagonal pyramid. Now, I want you to notice something when it comes to the surface area of the hexagonal pyramid and the rest. Look at this. When we're talking about pyramids, look at this. There is a pyramid, there is a pyramid, there is a pyramid. Something common will be in there, 1 over 2 PL, 1 over 2 PL. There is another one, surface area, again 1 over 2 PL. Even this one, 1 over 2 PL. So you can see that the part, and they are telling you here that P stands for perimeter. So it's perimeter times L, which is the slant height. Perimeter times L. So now we can ignore that, not that part. We can ignore these on the formulas and focus on these numbers here, this formula part. So this is what? This then becomes the surface area of a regular. So if I can find the surface area of that, like this, 6-sided, of that and that. So it's 1, 2, 3. Am I drawing this wrong? Remember, this must be a hexagon. So it's like this. For the hexagon, it's 1, 2, 3, 4. 1, 2, 3, 1, 2, 3. Where is that shape? Let me get this shape. They gave me the shape actually. It's this is the shape I want. It's 1, 2, 3, 4, 5. All right. So if I can bring that shape, so it's that, and then I've got that and that and that. Look at this. If I can find now the area, it is this particular area here that I'll put here. So that's the area of the base. Are you with me? So the base there is root 3 over 2b squared. That is the base. So root 3 over 2b squared. So let me write that part here to say the area of the base is root 3. Is 3 root 3 over 2p squared. So let me write that. It's A is 3 root 3 over 2b squared. I'm just keeping these formulas. And then remember, they show that the slant height of the hexagonal pyramid H is that. But now look at this. In these formulas again, but this alone won't give me anything. But I have got, there is another one, volume of a pyramid, because this is a hexagonal pyramid. So we need to know now, this is just the general one, the volume of any pyramid. Remember, this is a pyramid in the sense that it was going up like that. That's why they gave us it was like this, you see. So but this is what is important is what shape is the base. Hexagonal, it can be a triangular, so it can be like this, but still a what? A pyramid. See that? This is still a pyramid. It can be square like this, but still it will be what? A square pyramidal like this. You see, that's why here they are saying surface area of a pyramid with an equilateral triangle base, surface area of an equilateral triangular pyramid, surface area of a square pyramid. So all these are different pyramids. Okay, so now what you need then to focus on is the formula for the volume. Why? Because we know already the volume of this pyramid, so we can focus on this formula. Volume of a pyramid, which is 1/3 area of base times, that means perpendicular height. So it's 1/3 area of base times perpendicular height. I'll write that down again. 1/3 area of base times perpendicular height. These two, this is volume now, this is V. These two formulas are going to assist. What do I mean? So if I take these formulas here and use them for my next calculation, these are going to come in handy. Now look at this. We are saying here, I know the area of the base, this base here, that is shaded. So the area of this base here, that is shaded here, that is the one which was 3 square root of 3/2b squared. Are you saying that? So if I can use that to say volume V is equal to 1/3 and then area of base, which is bracket 3/2b squared. You see what I've done now? This is the area of the base times the perpendicular height, and then the height here is what they are looking for, which is the perpendicular height. So I'm looking for the h. So but I don't have to, but let me leave it like that. I'll keep on writing perpendicular height like that. But the good thing is I know the volume. They gave me the volume, and what was the volume? There is the volume 4,188.791. Why? Look at this. They said she decides to melt one sphere to make a hexagonal pyramid. So if you're melting, it means the volume won't change. So that's the tricky part. The volume is maintained. So I can now come here and say that 4,4188.7 here, 4,188.791, which is the volume here, is equal to 1/3 3 square root of 3/2. Now what is b squared? The b is the side of this regular hexagon. One side is 15 centimeters. So here that b, you say times 15 squared and then times perpendicular height. Then you find h. Let's see whether it will prove to what we have. So we can simplify what is this side first of all, which is in this case 4,188.791 is equal to, maybe not to complicate things, just simplify everything that is this side, which is 1/3 and then bracket, and then you've got another bracket which is 3 square root 3/2 and then times 15 squared. All right, then equal to, then you can write this number as much decimals as possible, 194,8557. I think it will be fine. 194,8557. So I've got 194,8557. There was a 19 something like that, but it's times perpendicular height. Then obviously perpendicular height, I want to remain with h. Divide by 194,8557 8551, so that you can cancel it out this side. But what you do on the left, you do on the right, 194,8551. So let's see what it will give me now as my answer. So it will be 4188,791 divided by 194,8551 equal to, which is 21,49695, which is 21,497, which is 21,497 is equal to our perpendicular height, but we're dealing with centimeters, I think. So let's check the answer. They say we exactly show that the perpendicular height of the hexagonal pyramid H is 21,497 centimeters. So you can say, therefore, H is equal to 21,497 centimeters. Are you getting that? So it's done. The next one is 4.1.3 here. What is it saying here? It says calculate the slant height, the L of the triangular pyramid, triangular face of the pyramid MN, the slant height of the triangular pyramid MN. So they are looking for this now, that slant height. But you can see now we have got a 90 degrees here, which is a right angle triangle here. So what you have is a shape. If I can draw it down here and then I'll bring it, it's like we've got this. We've got that shape, and something like this, and then we've got a 90 degrees there. This is a right angle triangle. Now the edge here, we know it already. It's 21, what? They told us the perpendicular height 21,497. Seeing that, and then they want this length height, which is our NM. So this is the N and this is the M, then this is the O, and then you know, in this case they told us the OM. They gave us initially, they say that distance OM, they say the line joining the center to the midpoint M of side KA has a length of 12,990. So here is 12,990. So you can see that this is the theorem of Pythagoras here that you have to use. And with the theorem of Pythagoras, what does it say? It simply says, if I can just divide it with Pythagoras, you know, it says here, I can say NM squared is equal to ON squared plus OM squared. That's Pythagoras. So if I want to find NM is equal to square root of ON squared plus OM squared. See that? So NM is equal to ON, which is 21 square root of course 21,9. Now this is ON 21,497 squared plus 12,990 squared, and then you can now find your NM. What will be that? Which is square root of 21,497 squared plus 12,990 squared. All right, so it is 25,1169, which is 25,117 to 3 decimal places. 25,117. Remember, we're dealing with what? Centimeters. So that's the part here. It becomes 25,117 centimeters. Are you seeing that? So that is the part here of NM. Then calculate the total surface area of the hexagonal pyramid. Total surface area. Now that is 1,1,4. Now if you go to the formulas again, the total surface area of the what? Now look at number 6. That's where we use number 6. Surface area of the hexagonal pyramid. And then they say that root 3 is root 3 over 2p squared plus half pl. So if I use that formula, I will just have to write it down to say surface area is equal to 3 root 3 over 2b squared plus half pl. Let's check it if I did it right. Right. So now we need to just know what is what. So we already know this part here, where the b, we remember the b was the 15, right? But now what about p? They told you p is the perimeter. Let me go back to the formulas. They're telling you that p represents perimeter of the base, and then l is the slant height. That's our l being the slant height, which we just calculated, or they told us the slant height. You can use that. We just calculate the slant height 1.1.3, which is nm. All right. So you can now use this formula to say surface area is equal to 3 square root of 3 over 2 times b, which is 15 squared like previously, plus 1 over 2. Now what is the perimeter of the base? Now perimeter means distance right around. So it means 15 plus 15 plus 15 plus 15 plus 15. That's the perimeter there. So we are adding 15 and 15 and 15 and 15 and 15 and 15. Now they're saying 15 times 1, 2, 3, 4, 5, 6. So we are multiplying 15 times 6. So which is 1 over 2 times 15 times 6. Can put it in brackets to say that's the perimeter part, times the slant height is the one that we just calculated here, which is 25,117. Here 25,117. They need to give us the answer. It's a bit long, understandable, so, but this you need to familiarize with. Square root of 3 over 2. So if I do that, this is over 2 times 15 squared plus 1 over 2. You can put a bracket, which is 15 times 6 times 25,117. I think that equal to, then if I didn't do it wrong, then you get area is 1714,83. 1714,83. Now what do they want? Calculate this surface area, which is centimeter squared. Are you getting that? So that is how you can find this. This was how many marks? 12 marks. All right, moving on. 1.2 still on geometry. This is analytical geometry. Says in the diagram below, triangle PQR, which is this triangle P, Q, and R. With P, they give you coordinates, and R, they give you coordinates, and Q, they give you coordinates. And then QR is parallel to TV. There is QR is parallel to TV. You can see by the arrows. V, they gave us V 0, minus 1,5, and T on PR. T is on line PR, and T on PR and PQ respectively. So now, what are they saying? Let's look at the questions. 1.2.1, determine the equation of line PR. 4 marks, line PR. So now let's look at the steps to find the equation of a line. The steps. Step 1, find M. M means gradient, and now if you look at these, they give us the formula for the gradient. Let me come back to the formula here. We have the formula of the gradient. There it is, M is changing over changing X. There is the formula here, which is y2 minus y1 over x2 minus x1. Okay, and then if we can use that, M is equal to y2 minus y1 over x2 minus x1. So we find the gradient. So we're going to find it. Number 2, use y is equal to mx plus c to find c. So let's do that. So we've got we can find the gradient here. What we have p is minus let me write that, p being minus 5 and 1, and r being actually not r, yes, r being, because it's pr, the equation of the line pr, r being 1 minus 2, which is 1 and minus 2. So I'm going to take these, put them there, and okay, let me take them back. So look at this, I've got these in here. I'm just going to put them nicely here, or actually put them down because I don't have space now. Okay, so look at this. If I've got these two, and now I want to find the equation of a line. So this is what our m, remember, this is my x1, this is my x2, my y1, and my y2. Remember the gradient. So if I said m here, that formula, m gradient of pr is equal to y2, which is negative 2 minus y1 minus 1 over x2, which is 1 minus, and then minus 5, which is negative 5. I think that, which is equal to minus 1 minus that is minus 3 over that 1 minus minus 5, which is 1 plus 5, which is equal to negative 3 over 6. Take a calculator, you can use it, which is negative 1 over 2. So that's the gradient m of pr. Then number 2, use y is equal to mx plus t to find c. So remember now, y is equal to mx plus c. I can choose one point. Let me choose this point where x is 1 minus 5, y is 1. So y is 1 is equal to m, which I know now. M is negative half minus 1 over 2, and then times x is negative 5 plus c. I think that this helps me to find c. So which is 1 is equal to, so it's minus 5 times this, which is 5 over 2 plus c. Take that to the other side, which is 1 minus 5 over 2 is equal to c. So what is c? It's 1 minus 5 over 2, and then I can subtract that, and it can actually give me the answer. So it is 1 minus 5 over 2, which is negative 3 over 2. So now the equation of the line, you can say therefore y is equal to m minus 1 over 2x plus c, which is negative 3 over 2. They give you 4 marks for that. That's saying determine the equation of the line PR, and then show that PR is perpendicular to QR. Let me do it on the other side. Show that PR is perpendicular to QR. Now let me talk about perpendicular lines. So if we're talking about perpendicular lines, there is a special thing that you need to know. It says for perpendicular lines, gradient of line 1 times gradient of line 2, you must get a negative 1. This is the property of perpendicular lines. And what do we mean when you say lines are perpendicular? You'll have a line, you have a line, and where they meet at 90 degrees. So if this gradient is m1 and this gradient is m2, when you multiply it, you get a negative 1. So let's do it. We already know the gradient of PR. So I'm going to write here to say it means m of PR times, because the question was what? The question is saying show that PR is perpendicular times M of QR times M of QR. I must get a -1. This is what it means. So now I already know M of PR. Now let me find M of QR. So if I say M, which is gradient of QR, remember the formula, it's Y2 minus Y1 over X2 minus X1, which is equal to, and we already know, let me write these 2 points here. It's much easier to say my Q is 4, 4, my R is 1 and -2. So then I can come here and say this is my X, this is my Y, this is my X, this is my Y, this is 1, 1, this is 2 and 2. See how I'm doing it? So Y2 is -2 minus 4 over Y, that is Y2 minus Y1 minus 2 minus 4 over X2, which is 1 minus X1, which is 4. If you use a calculator or whatever way you simplify, this will be equal to -2 minus 4 minus 6 over 1 minus 4 is -3. If you use a calculator, cancel that, this will give us a 2. So which means here the gradient of what? M of QR. This is gradient of QR. So if I can take it back here and say M of PR, we already know the gradient of PR from this formula here. Gradient of PR, M of PR was equal to -half. Remember from the previous line? So we can come back here and say M of PR, which is equal to -1 over 2 times M of QR 2 is equal to, if you multiply that, you get -1. Then therefore MPR is perpendicular to MQR. We have proven it. All right, moving on. Write down the equation of line VT. VT. Now look at this. There is a special property between T and Q. They say they were what? They were parallel. You must know about parallel lines. Gradient of QR is equal to gradient of VT. Why? Because for parallel lines, M1 is equal to M2. But now we know the gradient of QR, which is this one. M of QR, we got 2. So M of QR, which is 2, is equal to gradient of VT. So the gradient here, M of VT, is also equal to 2. Now using the formula, Y is equal to MX plus C, I can choose, yes, not choose, these are the coordinates that I need, whereby the X is 0 and the Y is -1 over 5. So I say -1, 5 is equal to M, which is 2 times X is 0 plus C. So you can see that -1, 5 is equal to C. So what is the equation of the line? Y is equal to M, which is 2X plus C minus 1, 5. This time it was this question, it was 2 marks. Alright, that is that. And then determine the value of the angle of inclination theta. So let's come here. I just want to show you, be sensitive now. When they come about this angle of inclination, go to the formulas and there is the formula. For theta is arctan M. So if I write that formula here to say theta is equal to arctan M, but since this inclination is linked to line QR, is M of, PR, is gradient of PR. So theta is equal to arctan, I need the gradient of PR, which I calculated here, M of PR is -half. But now, since it's negative, I'll say theta ref is 1 over 2. Forget the negative for now. Find the reference angle. Then I'll show you how to go about that. So when you do that, you say shift arctan, always take the positive. We call it the reference angle if there is a negative one. So it's 26,565. So it's 26,565. That's degrees. That is reference. Now, how do you find the actual theta there? So you therefore, theta is 180 minus theta ref. See, theta is equal to what? Which is 180 minus 26,565. So then you can find your theta here to give you, you can see that is bigger than 90. So 180 minus 26,565, which is equal to what? Which is 153,435. 153,435 degrees. That is the theta. And then with that, guys, what does it give you? 25 marks. Not bad. Again, it's geometry. You need to be a bit sensitive. Now look, in the next section, I'm going to look at question number 2. We will go through question 2. It's trigonometry, and we will continue. I think there was a question. It continues to 2.4. So join me in the next lesson where I look at trig and show you how you can go about passing or ensuring that you get all your marks on trigonometry. We've come to the end of our lesson. Thank you.